Hello mga learners! Welcome back! Today, we will learn about the biotic and abiotic factors in the balance of nature. Do seas dry up? Have you ever seen or heard of a dried up ocean or sea? Nature has a way of replacing the water that evaporates. Because of this, the nutrients and materials on Earth do not run out. This way, the organisms don't die at the same time. These phenomena and more are what this lesson is all about. After this lesson, you should be able to describe the different material cycles like carbon dioxide, oxygen, nitrogen, and water cycles. Differentiate a food chain from a food web. Explain feeding relationships among organisms. Differentiate prey from predators. And use acquired knowledge in preserving nature. An ecosystem refers to a community of living things and their relationships to their surroundings. It can be small like a flowering plant in a pot or big like the vast ocean. Look at the following diagram of a pond ecosystem. It shows all the functional components, biotic and abiotic, of an ecosystem. Biotic refers to the living organisms like plants and animals. Abiotic refers to the non-living things like water, air, and soil. A balanced ecosystem is key to the survival of all the organisms living in it. The organisms in an ecosystem depend on each other for survival. Look at the diagram. The chicken, or first-order consumer, feeds on the corn plant, or the producer. Then, the man, or second-order consumer, eats the chicken, or first-order consumer, and the cycle goes on and on. This diagram shows an example of a simple food chain. A food chain is a sequence of organisms arranged in such a way that each feeds on the organisms before it in the chain. Food chains differ in length. Most of the time, an organism may belong to several food chains in nature. Refer to the diagram. Let us consider one of the food chains in it. The shrimp, or first-order consumer, eats phytoplankton, or the producer. The small bird, or second-order consumer, eats the shrimp. The owl, or third-order consumer, eats the small bird, or second-order consumer. When the animals and plants die, bacteria decompose them. A protist eats the bacteria and the cycle repeats itself. The interlocking pattern formed by a series of interconnected food chains is called a food web. Cutting out even a single part of the web can have dangerous effects. After learning about biotic factors that affect the balance in nature, you will now learn about the effects of abiotic factors have on it. Are you familiar with the different natural cycles that occur around us every day? These cycles provide us with fresh air, raw materials for food production in plants, and provide the soil with nutrients plants need to produce food. In short, they help maintain the balance in nature. All these elements can be found in our surroundings. They are present in rocks, in the atmosphere, and in the other parts of biosphere. These cycles include the carbon dioxide-oxygen cycle, nitrogen cycle, and water cycle. Let's take a close look at each one of these. The carbon dioxide-oxygen cycle is also called the cycle of life. Carbon dioxide and oxygen are the two most important gases necessary for the survival of all living things. Carbon is available for life processes as carbon dioxide and as organic carbon. The two major carbon reservoirs are the oceans and the atmosphere. Carbon is converted into organic compounds through photosynthesis, the process wherein green plants produce carbohydrates from carbon dioxide and water using light energy from sunlight and chlorophyll. This occurs in terrestrial plants and in the macroalgae or large algae and phytoplankton or microscopic plants, found in both freshwater and saltwater bodies. Carbon is then returned to the atmosphere in three ways. First, direct diffusion in the air and water. Second, combustion or fossil fuels such as oil and coal, which are the remains of organic deposits laid down some 300 million years ago. And third, respiration, a biological process in which carbohydrates are broken down in the presence of oxygen into carbon dioxide and water, and in which chemical energy is released. The nitrogen cycle. Nitrogen is the basic component of all proteins and nucleic acid. In the nitrogen cycle, nitrogen moves in a large atmospheric cycle. Our atmosphere is about 80% gaseous nitrogen, or N2. Nitrogen has a very strong covalent bond, a chemical bond in which two atoms are held together by sharing a pair of electrons between them, which can only be broken by certain bacteria, volcanic action, and lightning. After the bond breaks, it enters the food web. Nitrogen atoms move through the ecosystem by nitrogen fixation, assimilation and biosynthesis, decomposition, ammonification, or the process of converting nitrogenous residues to ammonia, and nitrification, or the process of converting or being converted into nitrates or nitrites through the action of bacteria. During nitrogen fixation, the ammonia will dissolve and become ammonium, NH4+. Then the nitrogen becomes fixed in water by cyanobacteria, blue-green algae. Nitrogen becomes fixed on land by certain animals. Then plants assimilate and use fixed nitrogen in the biosynthesis of amino acids, proteins, and nucleic acids. During decomposition and ammonification, fungi and bacteria break down waste containing nitrogen and the remains of organisms. The decomposers use some of the released proteins and amino acids for their metabolism. Plants absorb the nitrogen that is left in decay, such as ammonia or ammonium. Nitrifying bacteria then absorb ammonia or ammonium. During nitrification, they strip the ammonium or ammonia of their electrons. As a result, nitrite develops. All of the compounds, ammonia, nitrites, and nitrates, are sensitive to leaching, or washing a soluble substance out of a solid by allowing a suitable liquid solvent to percolate through it and runs off. When nitrogen is lost to the air, the nitrification occurs. During the nitrification, bacteria convert nitrates or nitrites to N2 and some nitrous oxides. People can also affect the nitrogen cycle through pollution. Nitrogen-containing fertilizers and fossil fuels release pollutants that increase soil acidity. This affects the root absorption of magnesium, calcium, and potassium ions. As a result, the cycle loses more nitrogen. The water cycle. Water is an integral part of life on this planet. It is constantly being cycled between the atmosphere, the ocean, and the land. This cycle is a very important process that helps us sustain life on Earth. There are 6 important processes that make up the water cycle, namely 1. Evaporation, the process where liquid like water changes from liquid state to a gaseous state. Liquid water becomes water vapor. Although lower air pressure helps promote evaporation, temperature is still the primary factor. During the water cycle, some of the water in the oceans and freshwater bodies, such as lakes and rivers, is warmed by the sun and evaporates. During the process of evaporation, impurities in water are left behind. As a result, the water that goes into the atmosphere is cleaner than when it was still on Earth. 2. Condensation, the opposite of evaporation. Condensation occurs when a gas is changed into a liquid. It occurs when the temperature of a vapor decreases. When the water droplets formed from condensation are very small, they remain suspended in the atmosphere. These millions of droplets of suspended water form clouds in the sky or fog at ground level. Water condenses into droplets only when there are small dust particles present around from which the droplets can form. 3. Precipitation occurs when the temperature and atmospheric pressure are right and the small droplets of water in clouds form larger droplets. The raindrops then fall to the earth. As a result of evaporation, condensation, and precipitation, water travels from the surface of the earth, goes in the atmosphere, and returns to the earth again. 4. Surface runoff. Much of the water that returns to earth as precipitation runs off the surface of the land and flows downhill into streams, rivers, ponds, and lakes. Small streams flow into larger streams, then into rivers, and eventually flows into the oceans. Surface runoff is an important part of water cycle because through it, much of the water returns again to the oceans where a great deal of evaporation occurs. 5. Infiltration. An important process where rainwater soaks into the ground through the soil and underlying rock layers. Some of this water ultimately returns to the surface as springs or flows downhill. Some of the water remains underground and is then called groundwater. As the water infiltrates through the soil and rock layers, many of the impurities in the water are filtered out. This filtering process helps clean the water. 6. Transpiration. As plants absorb water from the soil, the water moves from the roots through the stems of the leaves. Once the water reaches the leaves, it evaporates, adding to the amount of water vapor in the air. This process of evaporation through plant leaves is called transpiration. In large forests, an enormous amount of water transpires through the plant leaves. Observe how the water cycle works. Notice that as the water evaporates, vapors rise and condense into clouds. The clouds move over the land and precipitation falls in the form of rain, ice, or snow. The water fills streams and rivers and eventually flows back into the oceans where evaporation starts the process anew. Let's remember, an ecosystem refers to a community of living things and their relationships to their surroundings. Biotic refers to the living organisms in an ecosystem, while abiotic refers to the non-living things in it. A food chain is a sequence of organisms arranged in such a way that each feeds on the organism before it in the chain, while a food web is an interlocking pattern formed by a series of food chains. There are many biological processes that happen in nature in order to balance our ecosystem. Some of them are photosynthesis, respiration, fixation, assimilation and biosynthesis, ammonification, nitrification, leaching, denitrification, evaporation, condensation, precipitation, surface runoff, infiltration, and transpiration. That's the end of our lesson on the balance of nature. See you on our next lesson.